All right, students, this is Mr. Bornheimer. I want to go ahead and start the first part of lesson 8-6. The first part of lesson 8-6 is going to deal with this idea of square roots. And this is a really important discussion when dealing with area because the two go hand in hand, especially when we're talking about the area of squares. So let's go ahead and start with a square. I'm going to start by drawing on my graph paper a 4x4 square. And I'm actually going to number it 4 and 4 all the way around. Now, what we want to do first in understanding this idea of square roots is we want to work with this idea that area of any square is going to be the base of the square times the height of the square. In this case, the area of this square is going to be 4 times 4. But instead of solving this, which we know it to be the area to be 16 units squared, we are actually going to take this and we're going to go in a slightly different direction. We're going to say this is the same thing as 4 squared. Now, if you recall, that little icon there means that we are squaring something. And that means that we are multiplying a number by itself. Okay, so let's just say that we know the area now for this particular square to be 16. That's all good, and we can write that in there, and that's going to be units squared, etc., etc. But let's say that you had a situation where you had this same square, so 4 by 4 by 4 by 4, but you didn't know its dimensions. So I'm going to go ahead and undo that. You only knew that it was 16 units squared on the inside. And so you knew that it was 1, you knew that it was a square, and 2, you knew that the area equaled 16 units squared. In this situation, you want to work backwards. And so to work backwards, what you need to do is you need to take the square root. You need to go back and try to find what two numbers, or what number, when multiplied by itself, will give me 16 units squared. That is the question. What number, when multiplied by itself, will give me 16 units squared? Now, we've already worked this through. You know that 4 times itself, so 4 times 4 is 16. But the way that this would work mathematically is that you would take that area and of 16 units squared, and you would do this. You would take that 16 and you would square root it. Now, that's not a division symbol. That's a square root symbol. And that's a symbol that's on our calculator. And you can actually see that over here on our calculator. It's the symbol that looks like that with an X underneath. That's the square root. So if we plug 16 into our calculator and we hit that square root icon, we get 4. What that what the calculator is doing there is that it's saying, it's going back and saying, it's splitting that 16 up so that it's finding the number that when multiplied by itself gives us 16. And the answer here is 4. So the area, the sides of this square equal 4 units each. Let's go ahead and do this now for another square. So this is going to be example number 1. What I want you to do is I want you to work this example backwards. I'm going to go ahead and give you the area of this square. And I'm going to tell you the area of this square is 81 units square. I want you to work this number backwards, and I want you to pause right now and try it. Okay, you should have tried this let's go ahead and work this problem. The first thing we need to do is we need to recognize that the area equals 81 units squared. We also are trying to find a number that goes here, and here, and here, and here, and that number has to be the same all the way around, because this, ladies and gentlemen, is a square. And by its very definition, it has 4 equal sides. So we need to find which number, when multiplied by itself, okay, so question mark times question mark will give us 81. That's what we had to figure out. So we go to our calculator and we type in 81 and we hit the square root key and the answer is 9. So for this particular square, we see that the sides are 9, 9, 9, and 9. And it's important to note that the sides will all have units, not units squared, but units, and the areas will all be units squared. Okay, let's do another example here. Example number 2. Okay, which is greater? The square root of 36 or 7? Go ahead and take a moment and try this problem. Okay, you should have tried this problem. The first thing you need to do is you need to get these two numbers so that they look kind of the same, and which means that you need to convert that value into a whole number or decimal. So let's go ahead and plug it in. 36 square root 6. So that is the same thing as 6. So which is larger, 6 or 7? Well, 7 is larger. So the answer here would be 6 is less than 7. Okay, and 7 is the larger value. All right, let's go ahead and do another example. Okay, in this example, I'm going to give you a number line, and I want you to place the following values on the number line. Now, the number line is going to start at 0, and it's going to go to 5, 10, 15, 20, 25, 30. And here's the numbers that I want you to place on the number line. So letter A is going to be the square root of 8. B is going to be 3.5. C is going to be 17 fifths. D is going to be the square root of 25. Point E is going to be the square root of 100. And the last value is going to be the square root of 125. So right now what you need to do is you need to place these 4 letters, or 6 letters, excuse me, these 6 letters on the number line. Ready, set, go. All right, we're back. First thing that you do in any problem like this is that you convert all of your square roots into whole numbers or decimals. Okay, so kind of go back here for a second. The first thing we do is we convert into a whole number or decimal. So let's go back to our example. Let's just start plugging in these numbers in. So 8 on the calculator, square root is 2.83. Now notice that this number goes on and there seems to be no pattern to it. We'll talk about that in a later lesson, but ultimately we're going to need to round here to kind of get our bearings. So the best approximation for the square root of 8 is going to be 2.83. Now we plug in the next one, which is D, 25, square root. That's going to be 5. That's one of our whole number answers. The next one we plug in is 100. square root. It's going to be 10. And then we do 125 square root. And that's going to be 11.18. Now, the only other value that we may need to put into decimal form is this improper fraction here. Okay, so 17 divided by 5. 5 goes into 17 3 times. That gives us 15. Leaves us with a remainder of 2/5. 3 and 2/5. Well, the thing about 2/5 is that is the same thing as 3.4. If you were to actually do that, 2 divided by 5, you would see that it's 0.4. Okay, so 3.4. Okay, now we plug in all of our values on the number line. We go to our smallest value first. So our smallest value, we're going to go ahead and do this in blue. Our smallest value is that 2.83. So 2.83 falls right about here. We're going to put the letter A. We're going to cross that off the list. The next smallest value is 3.4. So that's probably going to be just a hair higher. And that's going to be C. And cross that off the list. Then there's B, which is 3.5. We're going to cross that off the list. Then we have D, which is at 5. We can cross that off the list. And then we have E, which is 10. And then we have 11.18. I don't want to write the number. As F. So, again, we have A, C, B, D, E, and F. If we were listing these from least to greatest, they would be A, C, B, D, E, and F, which is almost alphabetical, but not quite. And as we go along, we just cross off the ones that we've marked. So that's example number 3. Okay? So, what we need to do at this point is we need to go ahead and look at one final example problem, and that would be the following. Estimating. Okay, so example number 4 says, I want you to estimate the value of each square root. The square root of 18 and the square root of 41. Okay, a little background. There is such a thing as perfect squares. So, what are these perfect squares that I speak of? A perfect square is anything that when a whole number when multiplied by itself. So 1 times 1 equals 1. Perfect square. 2 times 2 equals 4. Perfect square. 3 times 3 equals 9. 9 is a perfect square. 4 times 4 equals 16. And if you know your multiplication tables, you could do this for a while. We're going to go up a little ways. 5 times 5 equals 25. 6 times 6 equals 36. 7 times 7 equals 49. 8 times 8 equals 64. 9 times 9 equals 81. And 10 times 10 equals 100. These, ladies and gentlemen, are your perfect squares. 1 is a perfect square. 4 is a perfect square. 9, 16, and 25 are perfect squares. 36, 49, 64 are perfect squares. 81, 100, and the list can go on and on. Here's the thing. We're going to use this list. So, for this problem, we want to know approximately what the square root of 18 is. So, we know that the square root of 18 is going to fall somewhere in here. And here's how we know that. Okay, here's how we know. This is the same thing. If we look at this, the square root of 1 equals 1. The square root of 4 equals 2. The square root of 9 equals 3. And yes, this may seem redundant, but just bear with me. The square root of 16 equals 4. The square root of 25 equals 5. The square root of 36 equals 6. The square root of 49 equals 7. The square root of 64 equals 8. The square root of 81 equals 9. And the square root of 100 equals 10. So kind of just worked it backwards. Now, I just said that the square root of 18 would fall between 4 and 5. And that is because if you plug it into this almost like a timeline, the square root of 18 is slightly larger than the square root of 16, but less than the square root of 25. So if we did that, if we go ahead and estimate the square root of 18, we would say that it's probably somewhere around 4.5. We can check that answer. 18 square root 4.2. Okay, so that's a pretty good estimate. Your estimates, if you are estimating, should never be like 4.1 or 4.2. At best, an estimate using this would probably be something like 4.5 or 5. You're going to keep it kind of big. Remember, estimates are not supposed to be exact. Okay, so the next question is, where would the square root of 41 fall? So we come over here to our handy-dandy list and we say, okay, the square root of 25, the square root of 36, not there, square root of 49. Well, 49 is bigger than 41, and 36, so if I grab my highlighter here, 36 is less than 41, 49 is larger than 41, so our square root of 41 must fall somewhere in here. So we could say that it should be approximately equal to 6.5. Okay. Oh, yep, 6.5. So halfway between 6 and 7. If we plug 41 in and we take the square root, we'll get 6.4. So that is a good approximation. So 6.5 is an excellent estimate, okay, keyword here, estimate, for the square root of 41. Okay, that's example number 4. And I didn't have you try that one because I wanted to explain that process a little bit to you. All right, you're going to have some IXL homework to follow this lesson. And if you have any questions, please feel free to reach out. Otherwise, thanks for watching, and I will talk to you all later.